So question 9. A camera manufacturer spends $8,000 for facilities per month. So the quantities are important. Let's underline those. So this is per month. So this cost is per month. Then it costs $70, $75 to produce each camera. So those quantities we need to remember. How many cameras must the manufacturer produce each month? So this is each month to have an average cost, per unit of $100. So we want to make the equation out of this. So the equation, so the one side of the equation is saying the cost of camera. So we want to make both sides the cost of cameras. How many cameras to make? Let's call C many. Okay, let's say each month the manufacturer has to produce C many cameras to have an average cost of each $100. So the average cost of $100 is easier. Let's write on the right-hand side. Because the average cost of each camera is $100, and then we assume we have C many. So that's just 100 multiplied by C. On the other side, so we have net average. So we have $8,000 per month. So let's write down this one. So each month, we have $8,000. Then for each camera, $75. Each camera, $75. How many cameras? C many. So we have made linear equation. Right now, we subtract 75C on both sides, or move positive 75C to the other side, it becomes a negative. So 100C minus 75C is 25C, 25 cameras equals to 8,000. Divided by 25 on both sides. So C equals to 8,000. How do we divide by 8,000 divided by 25? We can think this way. We can think of 8,000 is 80 times 100 divided by 25. But 25 goes into 100 4 times. So then 4 times 80, 320. So the manufacturer needs to make 320 cameras. So the average cost would be $100. All right, that's the first one. Let's say 10. Taxi charges you a fixed charge, $5 per ride. Then $1 for every mile. How many miles must your taxi trip be for the average cost? Again, average cost per mile for $1.20. We do the same thing. So we see, okay, how many miles? We see M miles. M, use the variable M. You can use X. You can use any variable you like. So we want to make an equation. On one side, the average is $1.20. That's just 1.2. How many miles? M miles. The other side is $5 per ride, fixed. Then for each mile is $1. So 1 multiplied by M miles. We do the same thing, subtract 1M from both sides. Right? 1.2 M, subtract 1 M, get 0.2 miles. Then we divide by 0.2 on both sides. So let me rewrite it. So we have 0.2 M equals to 5. If dividing by decimal is troublesome, what you can do is this. You multiply by 5 on both sides. Why? Because 0.2 times 5 is 1. So 25 miles, right? 0.2 times 5 is 1, because 2 times 5 is 10, but you have the decimal place, 1 place. Right? So you get a 1. So 25 miles. Let's see, 11. Your taxing plan charges you $10 a month, then 10 cents per text message. How many text messages must you send per month? in order for average cost, again, average cost to be 15 cents. Well, let's see, we have T many text messages, to satisfy that. So equals to one side 0.15 times T many text messages. Other side, we have $10 per month fixed. Then each one costs 0.1. Each text costs 0.1, costs 10 cents, $0.1. Right, we do the same thing. We subtract 0.1 T from both sides. Or 0.15 T minus 0.1 T. Let's do this. 0.15 minus 0.1. We lined up the decimal place. So 5 minus, so this we can think as 0. 0. 1 minus 1 is 0. Decimal 0, 0. So we get a 0.05 T. That equals to 10. All right. So let's multiply by 100 first, because we want to get rid of this 0.05. Multiply by 100 both sides, we get 1,000 equals to, because 100 has 2 zeros, that kills those 2 decimal places, that equals to 5T. Then divide by 5 on both sides, so T equals to, think about 10 divided by 5, that's 2, so we get 200. So 200 text messages to be sent, then to get this equation, get a $10 per month and the 10 cents per text message is the same as the average cost of 15 cents per text message. Let's see these couple questions. So 12. It takes K 10 hours to pick 40 bushels of apples. So this is a work done problem, right? Remember work done problem. So it takes K 10 hours. That means K's speed of picking the bushes is 1/10 hours. And Margie can pick the same amount in 15 hours. So Margie's speed is 1/15. So she's slower. How long would it take them to pick 40 bushels of apples if they work together? If they work together, we just add up. So how long would it take? Let's say, let's call this a T. Then when they work together, the speed will be 1/T. Right? Then the speed, when they work together, we just add up the 2 speed, 1/10 and 1/15. We just need to add up those 2 fractions. So we multiply this one. Let me change my color. We need a common denominator. So common denominator, least common denominator is 30. So multiply 3/3, multiply 2/2. So 1 times 3 is 3. 1 times 2 is 2. We add up those 2 numerators and denominators is 30. Okay, so we get 5/30. That can be simplified. Divided by 5 in the numerator and in the denominator, that's 1/6. So 1/T is 1/6. So that means when they work together, the speed is 1/6. But what about time? We just flip over, so T/1, that equals to 6/1, which means T is 6 hours. Okay. So it takes K 10 hours. It takes Margie 15 hours, but if they work together, it only takes 6 hours. Let's see, 13. Ben can paint a room in 14 hours. If Ben and Jack work together, they can paint the same amount of room in 9 hours. So how long will it take Jake to paint the room by himself? Well, let's see, take Jake T time, all right? So when they work together, their speed is, it only take them 9 hours. So their speed is 1/9. That equals to the 2 speeds adding together, right? Ben's speed is 1/14. And we do not know Jack's, so that's 1/T. Now we subtract 1/14 on both sides. So get 1/t equals 1/9 minus 1/14. Well, 9 and 14 has no common factors. So what do? We can apply something called the butterfly method. We multiply those two numbers. So the denominator would be, we just multiply those two numbers, 9 and 14. And then 1 times 14 is 14. 1 times 9 is 9. And then the operation is subtraction. So just subtract. 14 minus 9, we get 5. Then we get 9 times 14. Because we need to approximate into hours. Let's just keep it as it is for now. So 9 times 14. And this is in hours. But in life, we would never, this is speed, right? Because 1/t equals to 5 of this. Now we wanted to find a time. So we flip over t over 1. Flip 1/t to be t over 1. Then we have to flip 5/9 14. 9 times 14 to be 9 times 14 divided by 5. So this is in hours, right? But we wouldn't tell people, see, it takes a jig, some number divided by 5 hours. We can tell them we have to convert this into hours and into minutes. So 9 times 14, now let's calculate. 126, right? Because 4 times 9, 36. So we carry on 30. Then 10 times 9, that's 90. 90 plus 30, 120. So 126 divided by 5. That's 125 divided by 5 plus 1/5. So this is a t. 125 divided by 5, that's 25. Oh, really takes him that long to finish it? Yeah. 125 divided by 5, that's 25. Then we have to convert, so 25 hours, then some minutes. So we need to convert 1/5 to be minutes. So how do we do that? 1 hour have 60 minutes, so we multiply by 60. 5 goes into 60, 12 times. So 25 hours and 12 minutes. All right. Let's see, 15. A dump truck travels 300 miles on a freeway in the same amount of the time it travels 175 miles on a country dirt road. If the rate of the dump truck is 20 miles per hour, less on the dirt road than on the highway, find its rate on the highway. All right. So the dump truck travels 300 miles. Okay, this is the distance equals to time multiplied by speed formula, right? Or time equals to, so this formula can be written as time equals to distance divided by speed. Or sometimes we need to write as speed equals distance divided by time. Because this gives us a hint to form an equation, same amount of time. So we want to form an equation in terms of time. So time for dump truck travel on the freeway is 300 miles divided by its speed, right? Let's call this speed freeway F. Let's call it freeway F. Then it travels 170 miles, the distance, 170 miles on a country dirt road. So let's call the dirt road D. The speed, this truck travel on the dirt road is D. You see, this is time spent for the truck on the freeway. This is time spent on the dirt road. But this is in the same amount of time. So that's why we have formed the equation. Now, we have an extra condition because we have 2 variables now, only 1 equation. So we need to have another equation. It says if the rate of dump truck, basically the speed of dump truck is 25 miles per hour less What does it mean? So that means D, remember D is the speed the truck travels on the dirt road. 25 miles per hour less on the dirt road. So it's F, then the highway, then the freeway or highway. That's F minus 25, right? So the two speeds are different in 25. And on the freeway is much faster, right? Because at the same time it travels 300 miles. And on the dirt road only travels 175 miles. So the speed on the dirt road equals to the speed of on the freeway or on the highway minus 25 miles per hour. So we have those two equations, right? We have this equation, we have this equation, and we have formed a system of equations. Now what do we do? Let me write it here. Now you see D is F minus 25. So we just substitute this D into F minus 25. So we have 300 divided by F equals to 175 divided by D is F minus 25. Now you see we only have one variable F now. So by substitution, we got rid of D. Now we can solve. How do we solve this? Let me change my color. We use cross multiplication. We multiply 300 with F minus 25. That equals to F times 175. That's right here. So 300 times F minus 25 equals to 175 times F. So we distribute 300. So we have 300F minus 300 times 25. 3 times 25 is 75. So 75,000 equals to 175F. Now we need to combine like terms. So we move 175 to the other side, becomes negative. We move negative 75 to this side, become positive. So 300F minus 175F, that's 125F equals to 75,000. Note that I have divided both sides by 125. Let me change my color. So 75. Actually, I don't really need to multiply 300 with 25. Let's keep this as 300 multiplied by 25. Right here. I multiply those two numbers, I get 300 multiplied by 25. Let's just keep it as 300 multiplied by 25. 25 goes into 125 5 times. Because 25 times 5 is 125. Then 300 divided by 5, that's a 60. So the speed the truck travels on the highway or on the freeway is 60 miles per hour. Right? Yeah, now let's see 16. Derek drove 18 miles to the airport, pick up his sister, and then return home. On the return trip, he drove 2 times faster than he did on the trip there. If his total driving time was 1 hour, total time, what was his driving speed to and from the airport? So we need to find both. One is to, one is from. Okay, so let's call his speed of driving is D. You can call anyone, right? So his driving speed for me, I call D, and his from speed, I don't know, maybe call F. That reminds me that's the speed of from the airport to home, and D means is to from home. No, let's say to. Let's use T. Okay, it's driving from home to the airport, the speed is T. And the driving home speed is F. So this says Derek drove 18 miles to the airport. So that means the distance from his home to the airport is 18 miles, right? 18, so we know the distance from both sides. From his home to the airport, 18 miles. From the airport to his home, 18 miles. So what do we know? We know the total time spent was 1 hour. So we want to make that equation. So the 1 hour equals to the airport time and from the airport time. So what is the to the airport time? That's 18 divided by his speed, right? His to speed from home to the airport speed. So that's the time. So 18 divided by his speed going to the airport. That's the time he spent going to the airport. Now, also 18, the distance doesn't change, and divided by the speed of his coming from the airport to home, and we call it F. Right, so we have made the equation. So the first one is the time, total time is 1 hour. 18 divided by T is the time he spent to the airport. 18 divided by F is the time he spent from airport to home. Now we need another equation because we have two variables. Another equation says he drove 2 times faster when he goes back home. So that means F, remember F is from the airport, so his return trip equals to 2 times T. Or allow me to write here. So we just change F. So 1 equals to 18 divided by T plus 18 divided by F equals to 2T. So let's change F to be 2T. Well, 18, we can simplify this. 18 divided by 2 is 9. So we have 18T plus 9 over T. 18 plus 9, 27. So we have this. We have 1 equals 27 divided by T. So what is T? So T, 1 times T is T. T equals to 27. So the speed for him, for he drive from home to the airport is 27 miles per hour. Then what about his return? Remember his return speed is 2 times faster, and we call it F. So 2 times 27, which is 54 miles per hour. Okay, that's a 6. Let's see 7. John started a race running at a speed of 6 miles. Half hour later, so this is given us half hour later, Kyle started running the race from the same start position at a speed of 7 miles per hour. So when will Kyle catch up to John? All right, let's draw a picture. So let's see, this is the starting point, right? So John started first. John started first. A half hour later, so this is a half hour. Then Kyle started. And John's speed is 6 miles per hour, and Kyle's speed is 7 miles per hour. So when will Kyle catch up with John? So which means at a certain point, right? John reached this point, and Kyle also reached this point. So which means that they have run the same miles. So we're going to make an equation based on that. Okay, the left-hand side could be the miles, the distance have to be the same because they started at the same point. So when Kyle catch up with John, that means the distance they run are the same. So let left-hand side to be the distance of John. So this is half hour. And we have no idea from half afterwards. Let's call this T. Okay, T hours. So after half hour, T hours, Kyle. So let's see, after T hours, Kyle, which will catch up to John. So John's speed at 6 miles per hour. At 6 miles per hour, and he ran half hours already. That means I have 3 miles already, right? Because 6 times half is 3 miles. And plus the rest of the time, t, 6t, because his speed is 6. 6 times t would be the distance after the half hour. So that's for John. For Kyle, he started 7 miles, so 7t. Because his speed is 7 miles per hour. And after t hours, he'll catch up to John. Well, 6 times half, that's 3. Right? We just move 6t to the other side. 7t minus 6t, this is 1t. So t equals 3. So which means after 3 hours, Kyle will catch up to John. That's it. Okay, t is 3 hours. So after 3 hours, Kyle will catch up to John. So basically, you see these word questions. We just make equations based on the context. Now let's say y varies directly as x. Remember, this gives us y equals to k times x, right? Varies directly, direct variation, the relationship has this, y equals kx. And when y is 84, x is 12. So we can solve for k by dividing by 12 on both sides. So k equals to 4. Now we can write as y equals to 4x, right? So the question is asking finding y when x is 17. This is 4 times 17. 4 times 7, 28. Carry on the 20. 10 times 4, 40. Plus 20, 68. Okay, so we use the first y equals to 84 and x equals to 12 to find the k, the constant k. Right? But more importantly, we need to remember the equation for varies directly. Well, 9 is varies inversely. Remember, varies inversely means that x multiplied by y equals k, or y equals to k divided by x. Oh, that's 8. In this case, it's 8. A times b equals to k. Right? A varies inversely as b, or say a equals to k divided by b. So when a is 42, b is 4. That means k equals to 4 times 42. 4 times 42, 2 times 4, that's 8. 4 times 4, 16. So 168. So finding a when b is 6. So the 160. So we have 160a divided by b, basically, right? But now b is given as 6, so I have 160a divided by 6. Well, first let's divide by 2. Divide by 2, we get 84. We get 3. And 84 divided by 3, so it's 80 divided by 3, we get 2, and we get 24, 28. Okay, so a equals to 28. So we just have to remember the relation. Okay, either remember this formula or remember this formula. Those two formulas are the same. So this varies inversely or inverse direction variation. Now let's see 20. The amount of gallons of gasoline a car uses varies directly to how many miles it travels. Okay, let's make 2 variables. The m representing miles. The gallons of gasoline, let's use G. So we get a G equals to K times M. If a car uses 15 gallons of gasoline, 15, well, it travels for 400 miles, so K times 400. We can solve for K by using this relation. So we divide by 400 on both sides. So K equals to 15 divided by 100, let's divide by 5, we get a 3. Divide by 5, we get 80. So K equals 3/80. Now the question asking, how many gallons of gasoline? How many gallons of gasoline? So we have G equals to 3/80 miles. So when G equal, how many gasoline will be equal to 3/80 when they travels 550 miles? Let's divide by 10, okay, rid of these zeros. Okay. 3 times 55, 165, divided by 8. That's about, let's see, 8 divided by 16 divided by 8 is 20. 5 is too small, right? Then because 0, 50, okay, 6, then 20 is 2, 5, right? So it's about 20.63 gallons, right? Or you could see about 21 gallons. That's about 21 gallons. So he uses about 20.6 gallons or 21 gallons. Okay, now let's see 21. So I'm going to finish the word question and then take a break. 21 is saying Amanda's wages vary directly to the number of hours she works. Let's see, she works W hours. You know what? Let's use H for hours. Let's wedge for W. So that means W equals to some K times H. If her wedge for 5 hours are that much, if her wedge for 5 hours, so times 5, are 29, so this is 29.75 cents. I'll have this equation. So we can solve for K. So K equals to 29.75 divided by 5, which we get, let's see, so 29, 5, then we have 42.8, 42, so this 42, 40, then we have 25, 5.85, right? So K equals to 5.85. Now the question asking, how much will they be for 30 hours? Right? So the wedge for 30 hours is 5.85 times 30 hours. Okay. So 3 times 585, 3 times 5, 15, carry on 1. 3 times 8, 24, carry on 2. 3 times 5, 15. So 17, well, we have 2, then we have a 0 from 30. We have 2 decimal places, so 1, 2 here. So it's about 175, so $175.50. Okay, so we use the first relation. Oh no, here. We use the first relation to find the constant K, then we plug in 30 hours. Let me erase this for the question 22. So now 22, the price for person of renting a bus varies inversely, right? Inversely with the number of people renting the bus. Okay, let's see, N many people. And the price per person of renting the bus, right? The price, let's call it P, varies inversely. That means P equals to K divided by N. So that's if it costs $12 per person, so if the price is $12, then people amount would be 60. So K equals to 12 multiplied by 60, which is 720. So that means P equals to 720 divided by hours. The price equals 720 divided by hours. Now question is asking, how much will it cost? What is the price when the cost per person is $75? how much will it cost per person? Right. If 78 people rent the bus, okay, that's 720 divided by 78 people. Well, let's divide by 2. Divide by 2, get 39. Right. Divide by 2, get 360. Now we have to round. So let's see. 360 divided by 39. So this, let's see, 8 or maybe 9. Yeah. So 9981, carry on A, and then 35. Right, so I have 9. 90, I have 0.2. So that would be 78. 12. Let's see if this is bigger than 5. So 120. 120, 90. So that would be 3. Right? 3. Yeah. So it's about, so how much would it cost? It would cost approximately $9.24. Right? So $9.24 for 78 people rented the bus. So that's a 2. Let's say 3. The length of a violin string varies inversely. So the length, let's call it L. As the frequency of its vibration, let's call the frequency of vibration F, varies inversely, that means L equals to K divided by F. A violin string 7 inches long, vibrates at a frequency of 490. So K divided by 490. So K equals to 7 multiplied by 490. Question, what is the frequency of a 10 inches long? So what is the frequency of 10 inches long? Well, now we know K is 7 times 490 divided by 10 inches long. It's only 10 frequency. Oh, hold on a second. Yeah, we know 10 inches long. We don't know the frequency. We want to find out the frequency. So F. Right. So let's multiply F on both sides. We get 10F equals 7 times 490. We divide by 10 on both sides. So kill this 0. So frequency equals 7 times 49. Well, 7 times 49, 7 times 49, you can think as 7 times 50 minus 1. 7 times 50, 350 minus 7, which is 343. So the frequency of vibration would be 343 cycles per second. So that's its unit, cycles per second. All right, so let's finish up here for now. Let me take a break. Now we'll keep going with the rest.